So here we have a nice exercise, friends. Find an identity for cosine to the fourth of theta using complex exponentials. So we got to write down a basic fact, a tool that is, which is that 2 cosine of theta, that's equal to e to the I theta plus e raised to the negative I theta. That's a well-established fact. So we are looking for cosine to the fourth of theta. How do we do that? Well, we can just raise both sides. So it's going to be 16 cosine raised to the fourth of theta. That's equal to that e raised to the I theta plus e raised to the negative I theta, and this whole thing raised to the fourth. Just exponentiate both sides. You can expand that expression there on the right side of the equals with Pascal's triangle to get e raised to the I of 4I theta, so this way, and then plus by Pascal's triangle, this would be 4e raised to the 3I this way, I theta, and then e raised to the negative I theta. And then from Pascal's triangle, next we would have a 6e raised to the 2I theta multiplied by e raised to the negative 2I theta. And then the next one again would be another 4e raised to the I theta multiplied by e raised to the negative 3I theta. And the last one at the end would just be basically e raised to the negative 4I theta this way. So that's Pascal's triangle. Now, to be able to wipe things away, to just convert to that cosine and sine notation. So e to the 4I theta becomes cosine of 4 theta plus I of sine 4 theta. Now this next term is going to be e to the 3I theta and the negative I theta. So when you add them, you're going to have a 2I theta. So it's going to be plus 4 cosine 2 theta and then plus 4 sine of 2 theta. So 3I theta minus I theta is 2 theta. That goes into the sine and cosines, and then the 4 gets distributed across. And then if I get the I in this position this way. Okay, for the next one, it's going to be e to the 2I theta. So 2I theta minus 2I theta is 0. So it's e to the 0, which is 1 times the 6, which is 6. Plus, and it's going to be here, I theta minus 3I theta is negative 2I theta. So it's going to give you 4 cosine of negative 2 theta. But of course, cosine is even, so you can wipe away the negative. Makes no difference. Now, for the side, you're going to have plus, let's see, 4 and then I side of negative 2 theta. Now side is odd, so that does make a difference. That means just move the negative out front. So you have 4I side of 2 theta. And then at the very end, we're going to have e to the negative 4I theta. So it's going to be, again, cosine of negative 4 theta, which is just cosine of 4 theta because it's even. But for that last one, it's going to be sine of negative 4 theta. That's odd, so it's going to become negative I sine of 4 theta this way. Now, let's see what stays and what gets wiped away during this process. So let's wipe some things away if possible. Okay. So now take a look. Cosine of 4 theta is present twice. So you're going to say 2 cosine of 4 theta. Okay, that's one component. Now this I sine of 4 theta right here, that's going to get wiped away with this negative I sine theta at this position. What else do we have left over? We have this negative 4I sine 2 theta, and we have this positive 4I sine 2 theta. So these two will get wiped away. And then we have 4 cosine 2 theta and another 4 cosine 2 theta. That is there twice. So that's going to give us then plus 8 cosine of 2 theta. And the 6 is just a constant, so you copy it once. So that means we've taken care of this, we've taken care of this, and basically this, we've taken care of this one, we've taken care of all of the terms. So that means what we have then is that 16 cosine raised to the fourth of theta there is equal to 2, pull the 2 out, and then cosine of 4 theta plus 4 cosine of 2 theta plus 3 is what we have. Then just divide by 16 on both sides. So that means cosine to the fourth of theta would be equal to 2 divided by 16 is an eighth. So it's 1/8 of cosine of 4 theta plus 4 cosine of 2 theta and then plus 3. And this is how you can get an identity for cosine to the fourth of theta pretty quickly using complex exponentials. A nice little exercise. Please be sure to leave a like and subscribe if you like videos at this more advanced level.